All right, looks like we're looking good. Thank you everybody for coming. This is Containers You Better Get on Board. I am Anthony Nocentino, just as Mark introduced me. I'm a consultant and trainer and founder of Centino Systems. And I have my contact info at the bottom there for you. It's going to show up again later. But do feel free to email me or follow me on Twitter and hit me up with any questions you might have about today's content or honestly anything about SQL Server, Linux, containers, things like that. I blog relatively frequently, so that's my URL there for my blog. And as Mark said, I'm also a Pluralsight author. I just released a course on Kubernetes, which I will tell you a little bit more about later. Kubernetes, not the course, or maybe both. I don't know. We'll try it. So let's talk about what we're going to talk about today. And we're going to cover a lot of material. We're probably going to go a little long because I do that often when I do presentations. But we're going to cover tons of stuff today, and hopefully you'll enjoy it. We're going to introduce containers. So if you've never seen a container before, this is your session. We're going to show you how to get started and how to get moving with all of this new technology. We're going to talk about containerizing applications and data centers. So what does it mean when I want to run a container in my enterprise? Like, what do I have to be concerned about? We're going to talk specifically about running SQL Server in containers and what are some of the, I don't say challenges, but what are some of the unique things that we need to look at when we run a persistent data application like SQL Server in a container. Now, since this is a 101 talk, we're going to take a little pit stop and look at the container universe so you guys kind of know what the buzzwords are, who the big players are in this field of technology. Then we're going to get hands-on and do lots and lots of demonstrations. I'm going to make the code available for you guys to download afterwards on my website, and I'll give it to Mark as well so that you guys can go and repeat the stuff that we did today in today's webinar. We are also going to talk about a concept called container orchestration. You're going to see there's some things that are a little bit peculiar about how to deploy containers in a data center or in an enterprise fashion, and you kind of need this thing called a container orchestrator. So we'll introduce its role in container deployments. And we'll also talk about some high availability container scenarios, how you can get HA almost out of using just simple containers in your SQL Server environment. And so here we go, starting off with introducing containers. What's a container? Well, a container is essentially operating system virtualization. Well, what do I mean by that? What I mean is that we're going to share the kernel and the system resources of the underlying hardware or the underlying virtual machine. So as my application, well, it thinks it sees one operating system, but I can have many applications that are running on top of that OS that each have an independent view of that underlying OS. So we're going to talk about the tech that makes it happen a little bit later. Now, what does a container contain? A container contains the binaries, the libraries, and a file system that represents the system as a whole for your application. So it's literally going to be the program that you want to execute and any supporting libraries and any additional files that are needed to support that individual program. All of the other resources will come from the underlying operating system. And so what do you see here? You see a container. This is a thing that will deploy, right? Our applications, so the binaries and libraries live inside of that unit, and that's our unit of deployment. And inside of a container, you'll generally speaking, just generally, you'll find one application in the container. There's some cases where you put more than one application inside of a container, but generally speaking, you'll find one single process that executes inside of a container because the container, when you're working with it, is going to be the unit of work. I like to think of it as just starting up another process. It's just a thing that starts up on a computer. Now, one thing that's interesting about containers is that they're ephemeral. What this means is if I stop a container and delete it and redeploy that container again from its base image, which we'll learn about in a little bit, I lose that information. And so we're going to learn as we go through this, especially since we're SQL Server pros in the hybrid virtual chapter, we're going to learn how we can add some persistency to this ephemeral world. Now, let's start off with a comparison. We're going to compare containers with VMs or virtual machines. That's certainly a paradigm that we're probably all familiar with in the SQL Server space. With VMs, well, we had a server, and on top of that server, we put a hypervisor. And it was the job of the hypervisor to multiplex access to the underlying hardware for us. And we still had to go and install a bunch of guest operating systems on top of the hypervisor to get access to, well, those virtual resources. And so each individual OS thought that it had full access to the underlying hardware. On top of that, we still had to go and install all of our individual applications. And we wound up with something like this. And I like to think that this is, well, high maintenance, right? Because we really didn't gain any value other than better utilization of the underlying hardware in how we manage and deploy our systems. We still have to install the apps. We still have to install the guest operating systems, and we still have to care and feed for this thing called a hypervisor. And I don't think we added any additional benefit other than better utilization of the underlying hardware in our platform. And so what's so hard about virtual machines? Well, primarily we look at things like OS resource overhead, right? We have to maintain multiple copies of an operating system up and running that are consuming CPU cycles. We have to patch all of those things, right? Every single one of those guest operating systems has to be loved and cared for and patched in a very efficient, modern kind of way. Now, one of the other stories I like to tell when I talk about patching in large enterprise environments, when I was in graduate school, I worked on cluster or grid computing systems where you had tens and hundreds and thousands of computers working towards the same computational problems. And one of the use cases I saw in a research paper for a load test was Windows patching, right? So if you're using Windows patching as an example of a load test inside of a grid computing platform, chances are that's probably not the most efficient utilization of the underlying hardware. Another thing that we look at when we're worried or we're working with virtual machines is troubleshooting. Each one of those guest operating systems and all those applications that are layered on top of that had to be cared and fed for and loved, right? If something went wrong with one of those things, well, as IT professionals, we'd have to put our capes on and go fix those things and resuscitate those systems back to life to make sure that we get our applications back online. Upgrades. I also like to say one of the hardest things that I do in IT is upgrade my operating system. When you think back about all the projects that you've been through and what are one of the more challenging projects that you've probably dealt with, replatforming desktops, replatforming server operating systems. These aren't easy things to do because all of your other things that you deploy are built on top of that. So you have to test everything out when you change out your OS version. Deployments. How many of us, usually if I do this in person, I ask people to raise their hands, but how many of us have completely automated deployments of virtual or physical machines and the operating systems on top of that? There's not a lot of people that have that level of sophistication on-prem. In the cloud, you mash a button and the server pops out, but that isn't something that we have, generally speaking, on-prem in our corporate data centers. And the question that you have to ask when we're looking at all of these things is, does any of this move your business forward? Does any of this make your company more profitable? Does it allow them to sell more widgets or whatever it is that they do in their business, right? And that's a kind of a hard thing for IT, right? We spend a lot of CPU cycles, pun intended, doing this stuff. And so now let's look at containers, kind of shift gears. I know I just beat up on VMs pretty hard, but they're pretty cool still. Don't get me wrong on that. Now let's shift gears and look at containers. Well, let's say we still have a physical machine. This could be a VM as well if we wanted to. We put a regular old host operating system on top of that. Could be Linux, could be Windows. There's different ways that we can multiplex the OS itself to support containers. We then can deploy our container on top of that. And so this application here, anytime it has to read or write to the underlying operating system or has to read or write to a network socket or anything like that, as long as the underlying host OS respects the system call that that application needs, it's going to service that call for it. And our applications think that they live in its own digital island with their own access to that underlying OS. That means we can come along and we can deploy additional applications on top of that individual operating system, and app 1, 2, and 3 no wiser of the other. If app 1 has to talk to app 2, it's going to do it over the network like it would any other application on any other server. And the benefit that this gives us is that that is going to be our unit of deployment. We can leave the host OS there and just drop a container onto that OS and get our application up and running. That entire thing is what we move around. And we'll learn about the technologies and techniques as we go through today's session. So I like to consider that this is lower maintenance, right? Because there's less surface area that I have to manage when I'm looking at this from an enterprise level. I also then care and feed for the things that matter, my applications that help me do things for my business. If I can move code out faster into production because I can deploy it more quickly in a container, then that's helping my business get things done. And so that leaves us with this thing about going fast, right? And that's the value that containers provide. It's all about going fast and getting things out into production more quickly, more efficiently, and more consistently than we do today. And so what do containers bring to the table? Number one, speed. A container itself is, generally speaking, going to be very, very small. Something as monolithic as SQL Server deployed as a container comes in at about 1.3 gigabytes right now. So I can pull that container from Microsoft, install that and run that on my operating system, and it's a 1.3 gig download. Anyone with a modern internet connection, that's just a few minutes to pull that down and get SQL Server up and running. I'm going to show you later today, after I've pulled the container down and it's up and it's on my local system, For me to stand up 1 or 2 or 10 instances of SQL Server on my local computer takes about as long as it takes for me to type the command in and press enter. Patching. We kind of minimize the need for patching because we're reducing the surface area of things that need to be touched, right? We do still have to care and feed for that underlying host operating system, and we do have to care and feed for the applications inside of the container, but I like to think that there's less things, there's less moving parts that I have to deal with when I compare to VMs, where I have to focus on both the apps and the dozens of operating systems and also the hypervisor and all of those things that have to come into play, kind of simplifying the technology stack to just the application and the OS. Troubleshooting. I'm going to show you a technique later where we're going to decouple the data and the computation of SQL Server. What do I mean by that? We're going to persistently store our data files external to the container, which means if something goes wrong with my SQL Server instance, I can just pick up the container, delete it, throw it away, and drop a new container down. And that is, well, going to be my troubleshooting method. I can kill that system and redeploy it very, very easily. Upgrades. Similarly, if I'm decoupling that data and computation in that SQL Server use case that I just described, I can bring down a new version of SQL Server attached to those databases with one command and have upgraded my system that fast. What does that get us? That gets us more fast and more consistent deployments for our applications, because now I can focus on the movement of my system and getting it closer to where I want it to be and rolling out new functionality. One of the things I do want to challenge IT people in general with is to start being more concerned about the services that you're providing, not the servers. So in that use case where I described exposing the SQL Server data in containers, is I want to make sure that we have that data available to be accessed by whatever needs to access to it. And I just put a container in front of the data so that it's reachable and readable off of whatever I'm using for persistent storage. And so we kind of want to get away from the philosophy of worrying about, PRD SQL 001 and making sure that PRD SQL 001 is online all the time. We don't really care so much about the individual server anymore. Is there a container there and available exposing the service to access that data? And that's kind of the shift that we're going to take in the next couple of years, I think, when we look at how SQL Server is deployed in the enterprise. And so back to containers again. So we saw this picture just a second ago, and just to kind of nail home the concept, if I need to patch, roll out a new version, whatever it is to app 1 right there, all I'm going to do is kill that container, download a new version of my application or the container image, and redeploy it. If the underlying host operating system respects all of the things that that new version needs, it will just work, and I've rolled out a new version of my application. What that allows me to do is get new code from my developers' workstations into production faster, right, and getting that functionality out more quickly. And we've all heard of the enterprises and things like that, or even online and the .coms and whatnot, that are deploying 10,000 times a day, 100,000 times a day. And these are the techniques that they're using to get these things done more quickly and get their code tested and into production quicker. And so what are the benefits of containerizing apps and our data centers? Number one, reduces development time, right? I can take that unit of work, that unit of deployment, which is the container image, scoop up that application off of my developer's workstation and get it into my testing environment and take that same exact unit and move it into production, which is pretty cool. A very linear pipeline of getting code out from developers into production as quick as we can. What we also have in that pipeline that I just described is deployment automation, right? I can write code to do that stuff for me. There's no longer do I have to go and log into servers and make imperative adjustments to my production environment. I can write code to describe what I want to have happen, what I want to do from a deployment standpoint, from a testing standpoint, any checks and balances need to occur before it rolls out into production automatically. And what this really does is enables these DevOps or CI/CD scenarios that you hear all these buzzwords about, but this is the tech that makes this stuff happen. Now, in the sense of running containers in our data centers, we do want to talk about a concept called orchestration, right? This isn't something that we're going to do manually by rolling containers out or starting them up like I'm going to show you in a little bit. There's going to be a concept called container orchestration, which we're going to review towards the end of the deck today, that does a lot of this work for us. Another concept that I want to bring home with containers in our data center is they kind of provide high availability in the sense that I like to think that if a container dies and is redeployed in a couple of seconds and I have access to my application again without any sort of clustering or high availability or load balancer or anything like that, but if my container died and automatically showed back up again and got me access back to my data, that might be a recovery objective that is sufficient for your business's needs. And so as long as that's okay and it meets your recovery objectives, you can achieve pretty good HA with just bare containers running your applications. Now, of course, there's lots of use cases and scenarios and what ifs there, but just think about the speed at which we can roll things out with containers and how that impacts the high availability of your application or just the availability in general. So again, I want to beat home that point. We need to rethink about how we're going to deploy our applications, and it's no longer the server that we want to care about. PRD, SQL 001, don't think about that. Do I have a service available, right? Do I have a container or whatever it is exposing the data or exposing the API that I want to have access to in my data center to get access to the information in my apps? Now that we kind of have the theory and the use cases behind us, let's look at the big players in the container universe. I love the Docker whale. It's the most adorable thing ever. You'll see this a lot in all of the documentation online and also when you're working with it locally in your workstation. But if the Docker whale ever gets sad and your Docker containers ever crash or anything like that, you'll see a little Band-Aid below its eye right there. It's super cute, the Docker whale. What is Docker? Well, Docker is really a technology. It's a thing, right, that is kind of or exposes what a container really looks like. It has since been open sourced and is available to freely develop and move forward. But Docker as a platform exists on Linux, Windows, and Mac, right? I'm on a Mac today. I know people that run Docker on Linux and also on Windows. And any of the containers that we're going to use today will run on any of these platforms, which is going to be crazy that I can pick up a Linux container and run it on my Mac or a Linux container and run it on my Windows machine very, very easily. Now, Docker Inc. is a company, right? Docker Inc. writes software that supports containers, things like Docker Swarm, which is a container orchestrator. And of course, they also write Docker, the software for the container runtime that exists on your local system. So when you go and download it, chances are you're going to download Docker from Docker Inc. But there are other container runtime engines. And so that container runtime being the thing that starts up the container and exposes and does all the management of exposing the underlying operating system into the container images that you have up and running on your system. And some of the other container engines available are Rocket, CoreOS, and even Windows. Newer versions of Windows in 2016 and 2019 all have the ability to support containers. Now, if you come from a BSD background or a strong Linux background, you might know what a che-root jail is. Well, effectively, you could say a che-root jail and the containers are very similar in how they present themselves, right? A che-root jail will give you a single view of your own process hierarchy and your own file system. And that concept is really what containers are built on. So let's look at getting containers and where do we get these things from? So like we know what a container is. Now we know what Docker is. Now how do we get containers onto our system so that we can use those to do these cool things that I keep telling you about? And the thing that we download or the thing that moves around in the environment that will come from my developer's workstation and go out into production, or it will download from the internet and get up and running on our system, that thing is an image, right? That image contains the code, right? The actual binaries, the runtimes, any libraries or environment variables to run the container. The registry is where these things live, right? Where the container images themselves live. So generally the big player in that world is going to be the Docker Hub, where you're going to find all the Docker images. Now there's other container registries available. You can have your own container registry. Microsoft actually recently announced, I think it was in PASS Summit this past year, MCR, or the Microsoft Container Registry. So the original versions of the SQL Server containers that became available were published on Docker Hub, and they're still there. But now anything new that's coming out is going to come out on Microsoft's Container Registry, or the MCR, and I'll show you how to interact with that during the demos later. Now there's this thing called a Docker file, which describe the container image. So maybe the program entry point, so the actual program that gets started up inside of the container, any network ports that need to be exposed, or any additional file systems or environment variables that are needed to start up the container. All that metadata is in the Docker file that describes what the container looks like once I want to have things up and running. And so here's kind of the pipeline of how this all works. So we start off with the image on our source workstation. We write a Docker file to represent what we want to do. And inside of there, we're going to have the app and the binaries, right? So all of this stuff is the container image. Now, when we're ready, what a developer will do is, well, they'll build the image and they'll push that image into a registry. And then what will happen is if we want to consume that image from our container registry, we pull it down. And then that is going to go get downloaded to the host operating system. If that host operating system supports the things that we needed to do, then our container is up and running. So a running image is a container. Now, when you're working with containers with containers from things like Microsoft and SQL Server, you're going to pick it up from the registry forward. And so basically, you're going to, from the registry, you're going to pull the container, and it's going to be up and running on your local workstation or server. If you're building your own images, you kind of go through this whole pipeline. And so let's look at the insides of a container. So we talked in the beginning about how it's a shared operating system, right? Exposing the underlying resources of that OS for the container or the processes in the container to consume. And what we have a requirement of is this concept of resource isolation. I need to make sure that app 1 and app 2 can't see each other, right, or interact with each other from a process standpoint. They have kind of their own swim lanes and think that they have their own access to the underlying host OS. And the technology behind this is the concept called namespace. It's originated from the Linux kernel and has since been moved over into the Windows kernel. It has a different name in the Windows world, but the concept is the same. But this thing called a namespace, which allows me to have my own swim lanes or my own private view of the resources exposed by the underlying host OS. And so some of the primary namespaces that are available are going to be for process isolation or the PID namespace, file system or the mount namespace, the network, net, interprocess communication, so these processes have their own way to communicate within their own namespace, but not between. Kernel isolation for critical kernel data structures available inside the kernel, so they kind of see their own representation of that. So now that these apps kind of have, and all these namespaces together provide a holistic singular view of that underlying OS, because this is pretty much anything a process would need to ask the underlying OS for. It's these 5 things right here. Now, how do you ask, like, how do I manage making sure that app 1 and app 2 don't step on each other's toes from a resource standpoint? And that's where we get some resource governing from a technology called C groups or control groups. And that allows me to assert some control on the container so that it doesn't consume too much stuff, whether it be network, CPU, disk I/O, memory, anything like that. Now, from a file system standpoint, there's this concept called a union file system. What that's going to do is inside the container gets a whole view of a whole file system. It thinks that it has all of that stuff. If it does have to read something from the underlying OS, or to use and make a change to that or modification, it will use a copy on write technology to basically bring that thing into the container image in what's called a layer, and that layer will then store that changed information in addition to what's from the container image itself, the change layer, and also what's available from the underlying host OS. And so all of that presents together inside the container as a union file system, so the OS or the container application just sees what it sees. So let's talk about data persistency in containers. We talked about this concept of being able to kill and redeploy a container. As long as my data is external to my application or to the container itself, that I can have access to again. So how does this all work? And let's look at the tech behind that and talk about data persistency in containers. So if your container is alive and you've made modifications to the data inside the container, just like I talked about a second ago, where I make a modification and it writes to the writable layer inside of the container, that data is going to be part of the container itself. So if I delete the container, that data is going to go away. And that's probably not what we want as SQL Server pros. And so there's some technology in Docker to help us overcome that and decouple the container from the underlying data or underlying storage subsystem so that we have a persistent place to write our information. And that's what's called a Docker data volume. And what a Docker data volume is a Docker managed resource that's going to be independent of the container. So I'll define in Docker that I want to expose some file space from the underlying host OS into the container. What this means is I can rip off the container for app 1, throw it out, redeploy app 1 again, and attach volume 1 to that application again. And there we go. We have persistency of our application. I'm going to show you how this works in pretty good detail when we get into the demonstrations. Now, I don't want to short sell persistent storage. If you go to this link here on Docker's website for their docs, this is one of those posts that I remember last time I looked at it. It's one of those posts where it tells you how long it takes to read the article. And last time I checked, I think it was like 42 or 48 minutes. It's a deep topic. And so if you are considering this in any way in production, go check out how to store data persistently for your containers, especially if you're doing anything with SQL Server. As a matter of fact, that's the next topic, SQL Server. So let's talk about running SQL Server on containers. Why? Like, why would we do this? Well, all of the reasons that we've been talking about so far, all of these cool things like deployments and upgrades and patching and speed and agility. And I'm going to show you how long it takes to stand up a new SQL Server in Docker when we get into the demos. And I honestly, when I do this in person, I kind of like look around the room to see, like, I want to see Jaws shop. That's what I want to see, because we're used to installing SQL Server and it not taking seconds. It usually takes a lot longer than that. The best automation that I have, I've written for a customer that I work with. The best automation to deploy SQL Server I see is around 2 minutes on some really fancy hardware. That's OS deployment and SQL Server on top of that. And that's not even eons near how fast we can do it with a container. And also, one of the other big reasons that I think this is really going to catch on as people kind of get into containers and see how they work and find the use cases in their own enterprises is, what if the unit of persistency is the database, right? Not the server anymore. We don't care about PRD SQL 001. We care about the databases on PRD SQL 001. Do I have access to the databases on PRD SQL 001, right? That's what I care about. I can throw that concept away and just make sure that I always have a container there available to access that storage, which is where my stuff actually is. All that other stuff is just fluff in our system. And so I really wanted us to think about that concept as we move forward and how we design our data centers and our data tiers. Now, when we're running SQL Server on containers, we have both Windows and Linux containers available to us from Microsoft. I'm going to primarily focus on Linux containers today. You're going to learn why in a second. If you want to pull and work with Windows containers, go ahead and check out that link there for use on Windows containers. We're going to work with Linux containers today because of this. You can't use Windows containers in production. I imagine it's something that will come in the future because it would make sense. But right now, the only container-based deployment for SQL Server that's supported by Microsoft is using SQL Server on Linux, or the Linux-based container. One of the other things I think that gets some people is that there's not Windows authentication on SQL Server on Linux, but we can get around that. Let's go ahead and get into some demos. So here we go. We're going to do some demos. We're going to pull an image, right? We talked about what images are. We're going to kind of come down from a container registry, and we're going to then start up or run a container on my laptop here. We're going to access the application inside of that container. It's going to show you how you can deploy, get a container up and running, and how you get into there to access that information. We're going to connect to our container, go inside the container, kind of look around a little bit at the internals, and then we're going to focus a lot on persisting data with containers. And so I can show you guys how to decouple those two things, tear off a SQL Server container, throw it away, and then get a new one and put it right back. And so here we are in VS Code, and I'm going to use VS Code to run the demo, and so that I don't have to type all of these commands over and over again. So you'll see me highlight and execute the code, and it's going to output's going to show up in the bottom right there. So all I did right here is I loaded up an environment variable, so I don't have to type that over and over again. Make sure I'm in the right directory. And the very first thing that we're going to do is I already have Docker installed, and don't worry about installations of Docker. I have some notes in the resources of this deck to help you get Docker up and running. If you're on Windows, next, finish. If you're on Mac, you drag a little icon around. So pretty straightforward to get Docker onto your system. Once you have Docker installed, you get access to this command, Docker, and Docker, well, takes some command line parameters. And the first one I'm going to show you today is search. We can search for something. I'm going to search for a container named mssql-server, and I'm going to pipe that output to sort because I want it in a particular fashion. So it's going to run that. It's going to interact with the Docker Hub, and here we can see all of the images that are available on this. In this case, this is coming from Docker Hub, not MCR, but we can see that Microsoft has their official image available here in their Docker Hub. And so now what we're going to do is we're going to go ahead and pull, I was using an older version of this deck because this is actually pulling from Microsoft rather than MCR. So I'll update this before I distribute this to you guys, but this will still work for this demonstration. So here we're going to use Docker. We're going to pull the image from Docker Hub and Microsoft. So we're going to pull the latest 2017 image. It's going to run that again. It's going to pull that down. And so here we can see that we executed the command. It's going to pull the latest image from Microsoft. Here's a digest representing, it's a binary digest of the Docker container image itself, so that we have some security around that what was uploaded is actually what was downloaded. And we now have downloaded a newer image. And so if I do Docker images, I'll get a list of all of the images that are available in my system. So here you can see I have the MCR images available on my local system, but the version of the code that I'm running at the top does not. And I'm not going to update that mid-demo because you know why. The demo gods would be sad. So I'm going to leave that alone, and we'll work with that Microsoft image. Now, what I'm going to do here is I'm going to use a command called docker inspect. What am I going to inspect? An image. So here we see docker image inspect, and I'm going to work with the container image that we just downloaded. I'm going to pipe that output into more so it doesn't run off the screen. And here we can see what are the internals of that container image that we've downloaded. We can see it has an ID. It has some repo tags to help identify the image itself. So in this case, you see 2017 latest as one of the tags. If you needed to roll back to a particular version, Microsoft has container images that represent each version of SQL Server that they've published. 2017 latest will always point to the latest Docker image that they have deployed. So let's go ahead and jump down a little bit and start up our container. Now, docker run is the command that we use to start up a container for the first time. Here you see I have this little slash right here in the end. Generally, this will be one command from left to right on my console. But what we're going to do here is use that to help it get it all on one screen. So it allows me to go down to the next line and run this all as one command here. So let's go through our docker run options. So we need to supply some environment variables to start up the container. We introduced that concept when we talked about what a container is made of, right? Binaries, libraries, and also environment variables. And that helps us configure the things inside of the container because the container image itself is immutable, right? It's this read-only thing. And so I need a way to be able to assert some configuration into the container to get it where I want it to be. I'm going to give my container a name because I want to be able to address it easily. I'm going to call it SQL1. I'm going to expose that container on a port on my system. Initially, I'm going to expose it on 1433 so that other systems can interact with this container image on that port on my network. Inside the container, that application is going to live in 1433. Because of those namespaces that we talked about, they have their own view of the world. And so container applications will write to their own TCP ports inside the container. And that's going to pop out of the container on the local port on my underlying OS. So that's what -p does there, maps that out to the underlying operating system. -d is detach, which is going to basically take the container when I execute it and run it and put it in the background and not output the console what's up and running. And this is the container image that I'm going to run. So let's go ahead and do that together. I'm going to take all this code, highlight it, and run. There you go. I've just downloaded, installed, and got up and running a SQL Server container. And so right now in the background, SQL Server is doing its thing. So before we get into the container, docker run is one of the more complex commands. So here's how you access help if you ever need that. We say docker help run. I'm going to pipe that into more because there's many, many options. And here you can see some of the options that are available with us. I can influence block IO. I can influence my C groups. Let's see what else we have. We have some CPU quotas. So some pretty deep dive stuff there if we need to adjust how our container is running in our system. One of the other things that you might want to look at before you get into your container, maybe it's not running. Maybe it's not up and doing what you want it to do. And one easy way to troubleshoot that is Docker logs. So we say Docker logs and then the name of the container that we just got up and running. I'm going to go ahead and run that. So what we have here is, if you look closely, what we actually have is the SQL Server error log. The SQL Server error log, when you're working with SQL Server on a console, writes the standard out. And it's the job of Docker to take that standard out and store that for you to access as part of the container's execution environment. So I can say Docker logs and access the standard out of my application. So this being our SQL Server error log, if something bad happened when I started up SQL Server and it didn't start for whatever reason, this is the first place I'd go to look. Usually it's because my password wasn't complex enough and it won't start the container. But there could be other reasons, and that's going to be a pretty good way for you to troubleshoot how to figure out why your container is not running. So we have an image downloaded. We got a container up and running. We looked at how we can access some of the data about the container. Let's look at some containery stuff. And the way that we do that is with Docker PS, right? We're going to use Docker PS to list all of the running containers on this system. In this case, I have one that's running right now, just one container. And from left to right here, I got a little word wrapping going on. We can see the container ID, which is this unique identifier right here. We have the image, which is what we downloaded together earlier, the 2017 image from Docker Hub. We have the command, which is the entry point into our application. Remember, containers generally run one process, or at least they start one process, and inside the container they might start additional ones, which I'll show you. But in this case, it's going to start up SQL Server, which lives in opt MSSQL bin SQL Server. That's the actual binary that's up, running, and executing. Created 2 minutes ago, and it's been up for about 2 minutes. Here we can see that it's listening on 0.0.0 so on any IP on my laptop here, or if this was a server in my data center, this would be on any IP running on 1433, and it's sending the data from that port into the 1433 port inside the container on 1433 as well. And the name of the container is SQL1. So with that, I can access our application. I'm going to use SQL CMD, and I want to say SQL CMD -s, and I'm going to connect on localhost, and I'm going to define the port that I want to connect to. I'm going to define a username and a query that's just going to say @@ server name, and I'm going to pass in the password there. And here we can see it runs it out, or runs that command or that query, and gives me the output, which is the container ID. We saw a little bit earlier that that was a container ID from Docker PS. So that's what @@ server name is inside of the SQL Server. Now, I want to ask, well, how can I do more than one SQL Server, right? This is really cool. So I say Docker run, same environment variables as before, but this time I need to give it a different name to uniquely identify it. I also need to give it a different port. And so it's going to listen on my local OS on 1433, and it's going to route into the container on 1433. So my apps will connect here. I'm going to detach it again, and I'm going to run that same image. So that one image feeds both containers. Boom, I now have 2 SQL Server instances up and running on my system here in Docker PS, and I see SQL1 right here on 1433, SQL2 on 1434, and if I want to, I can access that second application on 1434 right there using SQL CMD again, asking for @@ server name. There we can see a get into the container that ends in 4BC for SQL2. That's the recommended way to run multiple instances of SQL Server on Linux, actually, from the product team, is you run multiple containers on separate containers. And so one image sourcing both of those. So we get the benefits of having that 1.3 gig download, feeding both of these, and getting them up and running. So let's do some fun stuff now. So we have 2 containers up and running, and we're going to restore a database to those containers. And what we're going to do first is we're going to use a command called docker cp, and I'm going to take wide world importers from my local system, and I'm going to copy it into SQL2, or the container SQL2, into this location right here, var-opt MSSQL data. So it's going to run that, and it's going to take that from my local machine and copy it into the container. So pretty fast to get that done. It's all a local operation. I'm now going to run a script to restore that database. So I'm going to feed in to SQL CMD just the right stuff to restore that database, and I'm going to go ahead and run that code now. And so behind the scenes, what's happening is, since the container knows, since that backup is inside the container, the code that I'm executing reads that file and creates all of the appropriate things and resources on the local system while it restores that database. And so once that finishes, we'll get access back to our console here. There we go. And to show you that, I'm going to do something that's, I think, is kind of interesting. I'm going to go into the container now. And what does that mean? So we know from when we visualized this during the presentation portion, when we looked at app 1, it was kind of like up in the corner. So basically, I'm going up into the container, and I'm going to act as a process inside the container. What process am I going to act as? Bin bash. What that's going to do is give me a console into the container. So here's the root @ then the container ID / hash mark indicates that I'm in the root directory as a root user with the hash mark there. And so to do that, to get into our container and run that process, we do docker exec IT. I like to think it's for integrated terminal. The container name or ID that we want to use, and then the process we're going to launch. It doesn't have to be bash, right? To get it could be an arbitrary process. In this case, it is bash, which allows me to get an interactive terminal into the system here. So there we can see that we're on that box. And so we'll go through some commands here to show you what's going on inside the container. So if I do a ps -aux, which is the command to list all of the processes that are running inside my container, I see 4. Right? If you've ever worked on a Linux system before, even the most bare bone ones has a lot more than 4 processes running. And the reason why we see this is because of the PID namespace that we introduced when we looked at the internals of what a container is. And so here we see opt bin, or opt MSSQL bin SQL Server, right? That's the entry point in the container, and that's the process that got started up. It sees itself as PID1, which actually PID1 on a non-container-based Linux system is actually a special process that initializes the system. But in this case, it's PID1 because of the process or PID namespace. Due to the architecture of SQL Server on Linux, there will be a second SQL Server process. You can see it has a numerically higher process ID because that was allocated at some point in time after the initial process started. Here's our process right there, and of course the PS minus AUX process that we ran. So we get this view of the world, which is totally isolated from anything else that's running on this computer. Normally we would see all of the other processes and things that are executing on our platform, but due to the container, we have this private little place that we can run our SQL Server in. So let's take a peek at var opt MSSQL data now. We're going to do that. We're just going to get a directory listing and look at the file contents of what we copied into the container, right? This var opt MSSQL is inside the container image right now. We ran that restore. So here we see wide world importers, LDF, MDF. Here's the backup file that sourced it because I copied it in there, and all the other system databases that represent our SQL Server instance. So all that lives right now lives inside the container in var opt MSSQL data. And so let's go ahead and get out of the container and stop the container. So now we're shutting down SQL 2. So what happens when you Docker stop is it's going to send a sig kill of the process that's running inside, which is SQL Server. And since it's a relational database engine, it's going to take a second to shut down and clean up the resources. And so that might take a little bit to shut down when you stop your containers. Don't get too worried if that takes a few seconds. Now let's take a peek at our running containers, Docker PS. We still see SQL 1, it's up and running, but SQL 2 is stopped. If we want to see a list of all of the containers, regardless of their status, Docker PS minus A. So there we see SQL 2, SQL 1. SQL 2 status is exited 0. Exited 0 means clean shutdown. Anything else? You might want to Google what that number is inside of the status, because it's probably non-zero being an error. So if I want to start that container back up again, we didn't delete the container. We're just starting it back up again. All the data that was in SQL 2 is still there. And so if we want to go ahead and access that information, we could run that same code that I showed you earlier, and we would see all of the databases and whatnot inside of SQL 2. There we can see we're back up and running just a few seconds ago. So let's go ahead and stop all the containers. This syntax here, Docker stop SQL curly brace 1.2 is a concept called bash expansion. And so actually the shell will break these out into two separate commands and shut both of those down for me. We'll see Docker SQL 1 and SQL 2 both shut down in sequence. And so those are now both exited 0. So that's not a Docker specific technique, but just a Linux bash shell specific technique. If I wanted to stop everything on my system, I could use that right there, that syntax. This was looking for anything that began with SQL and ended in 1 or 2. Now I'm going to remove the container, in big caps here. This will delete the data that's inside the container, right? That SQL 2 we restored the database in, that stuff is all inside the container writable layer, and that's now gone. Uh-oh. Just kidding. So if we want to delete all of the running container or all of the containers on our system, we can use that syntax there. Of course, I left that commented out because that would be bad. Now, if I go and I look, I still have my Docker images. Right here we see I have an Nginx image, which is a simple web server. I have the MCR image from Microsoft, and I have the Docker Hub image. Oh, out of coincidence, look at that. They're both the same image ID. I figured there would be a newer version of this one, but they're both at the same image ID, which means they're the same image, even though they're coming from two different registries. So Docker PS minus A, nothing up my sleeve, no containers on the system, right? All we have right now are images because we pulled them down. They're on the system locally. We're now going to do some stuff and start up some additional containers. But this time, we're going to add an additional parameter to our startup properties. We're going to add -v, SQL data 1, var opt MSSQL. Let's walk through what all this does. -v adds a persistent volume. I'm going to name that persistent volume SQL data 1. So that's that addressable unit that Docker is going to manage for me. It's going to store that in a default location in the underlying operating system, and I'm going to show you what that is in a little bit. Now, that volume that's going to be stored in the underlying file system on this computer is going to be mapped inside the container at this location in var opt MSSQL. So what that means is when I take my container now and I launch it, I'm going to get access to var opt MSSQL, which is where all of my databases will live. And when I take SQL Server and I pick it up and throw it away, which I'm going to show you in a few minutes, and I drop a new one down, I'm going to present SQL data 1 in that same exact location, and those databases will be living in the underlying file system there, but they'll be presented back into SQL Server there, which means SQL Server will know where they are. And so that new container that comes along will have access to that information immediately. And so let's go ahead and do that together. So here we are, we're going to spin up that container. It takes just a few seconds to get going. That's provisioned the volume. So now I'm going to do that same example that I did a second ago, where I'm going to copy wide world importers into the container. So SQL data 1, it's going to go into this location. So in the container, we're going to have, and I'm going to go ahead and restore that real quick. Ooh, I don't like when this happens. This happened before last time I did this demo. What I will show you is this. What should be happening right now is I'll restore the database into the container. Then I attach to the container and I say, hey, container, give me the list of the databases that you have. So select a name from sys.databases. Now, what the demonstration should be doing is stopping the container and then removing the container, right? Which I just did a couple of times. And then I reinstantiate the container from scratch, right? So back to the container image itself. So I'm going back to this point in time from the container. But what I'm going to do is I'm going to mount SQL Data 1, which is now going to have master, model, tempdb, all of the system databases, and the user database that I would have restored with restore wwi.sql. Now, when SQL Server goes and starts up this container, it's going to look in this directory for the master database, and it's going to see the registration of the wide world importers in the master database, and it's going to go look for that and mount that up. And so effectively what we do here is by starting the container, restoring the databases, stopping and deleting, and then instantiating a new container from the base image, is we're taking that SQL Server, we're picking it up, throwing it out, bringing a new one back down, and starting it up right on top of there, having access to the data files in that location. And then if I run this again, we would see that our list of databases would be available in that location. Now, the tech behind that is this thing called a Docker volume. A Docker volume is a resource managed by the underlying Docker subsystem on my laptop here, or whatever computer that you're working with. So say Docker volume ls to give me a list of all of the volumes that are available. And here we see SQL Data 1, that being a driver or the Docker managed resource. Now, there's different types of resource or storage subsystems that we can have. In this case, I'm using local, but there's many different other storage providers that are available to have your system have access to storage that might be external to this actual server itself. Now, again, we can use the inspect command like we did with the Docker image up top, and we say Docker volume inspect. What do we want to look at? SQL Data 1, and we can see where it actually lives on this system, and it lives in this real location on the underlying OS at this name here. So this location is what's actually being presented into the container at varopt MSSQL. So with that, we can go ahead and kill off our container there, remove our container, which is all gone because I had those demo fails a little bit ago. When I delete this is when that persistent data goes away, like now. And so if we want to delete the images, I have some additional code in here to delete the images. I also have some additional code in here if you need to search for patterns for deleting things. And so that's all available inside of there. And so let's jump back into the presentation portion and wrap up with container orchestration, and we'll go into a Q&A real quick. I know I'm a little bit in the red zone, but I appreciate you guys hanging out. So container orchestration. Now, we have some questions that we have to ask ourselves when we want to run containers in the enterprise. Primarily, where do we want to run those containers in our data center? And that's one of the primary answers or primary features that container orchestrators provide, right? They do workload placement on the physical systems or the virtual machines that we need to stand up our containers on. Conceptually, what a container orchestrator does is manages state. What that means is it has the job of starting up your containers and making sure that they stay up. It also provides entry points into your applications and load balancing of services. So when I talked earlier about let's focus on the service and access into the application, well, that's one of the primary abstractions that a container orchestrator will provide for you. It'll put a service in a persistent location on your network and allow you to have access to that service over time. As the container is kind of coming and going out from underneath that, that's the job of the container to make sure, or that's the job of the orchestrator to make sure that the container is there for you. Furthermore, without having to worry about things like Docker data volumes and things like that, it's the job of the container orchestrator to provide persistent storage for you to access or to request for your containers to consume. So we don't have to worry about wiring up local directories on individual servers. That's going to be something that the cluster of your container orchestrator will manage for you. Container orchestrators also provide a declarative model, which means I can describe my configuration in code for the desired state of my applications, which is a very, very powerful technique on how we want to build next generation systems. We tell the service or the container orchestrator what we want our system to look like. And it's the job of the container orchestrator to make that happen for us. And so let's look at some of the big players in the container orchestrator world. Number one is Docker Swarm. You might have heard of this thing called Kubernetes. Well, that's what Kubernetes is a container orchestrator. Red Hat OpenShift is Red Hat's branded implementation of Kubernetes, and I think is the primary reason why IBM bought Red Hat last year for billions of dollars, by the way. And so that tells you the value that IBM puts on something like OpenShift or Kubernetes. There's Azure Kubernetes Service from Microsoft. There's GKE from Google, and there's also EKS from Amazon. So those last three being managed services from the cloud providers, the top three being software that you could actually download and install on-prem. So let's look at that concept of a service or a persistent service inside of a container orchestrator. So here, kind of the outer boundary is a cluster, and a cluster consists of many machines. Could be physical, could be virtual, in this case physical. And I have applications up and running as containers on those underlying host operating systems. Well, what I want to do is I want to have people be able to access these containers and point my clients to a particular location on my network. So I define a service, and that's going to be an IP and generally a TCP or UDP port that I'm going to persistently expose in my data center to point people to access things like application one. Now, the container orchestrator's job is to go and make sure that there's containers underneath this service to service the requests of the container itself. And so in this case here, you see app one running on multiple hosts as containers, all registered as part of service one. Now, it's the job of the container orchestrator to deal with situations like this. That container dies, all right? Well, what it's going to do is deregister that container from the service and continue to send load to the other containers that are servicing that application. It's also the job of the container orchestrator to do this, put a container back and re-register that container into the service again. And if you told it to do that automatically, it'll do that for you. This is one of the big values that I think containers provide, is that self-healing automated deployment of container-based applications. And now let's shift gears from regular old applications to something a little more advanced that we would do in SQL Server. Let's say in our cluster we define a persistent volume, which we established a little bit ago as how we can store data persistently external to the container runtime itself. We then define in our cluster this thing called a replica set, which is a Kubernetes construct that basically tells Kubernetes to make sure that there's always a fixed number or a defined number of a particular type of container running at all point in time. So in this case, I'm going to say, hey, Kubernetes, I want my replica set to keep one SQL Server container up and running at all times. And it's going to do that for me. I front end, or I put the data on the back end in volume one, and I front end that with a service. And so this hierarchy here gives me persistent access into my application with the service, which I would expose onto the network. The replica set's always going to keep a container up and running inside of Kubernetes, and it's also going to present my data storage persistently into volume, or as part of volume one, and attach that to SQL one because I've defined that in the code that represents this implementation inside of my Kubernetes cluster. Now, if that container dies, it's the job of Kubernetes to start that container somewhere else in the cluster, and it's also the job of Kubernetes to make sure that it reattaches that storage for me. If that storage is available on the physical machines or the virtual machines that are members of my cluster, it'll simply reattach that on that other node. My users go back into accessing their data tier applications with no issues at all, and my pager didn't go off. Now, in this scenario here, we basically achieved high availability with no special SQL Server technology. I mean, we added like some other complexity in Kubernetes and all that fun stuff, but that's a platform where we can store other applications and gain those benefits of high availability for other parts of our app tier. We're not using SQL Server specific technology anymore. We're using platform technology to keep our system in a desired state. So what's next? Are containers production ready? That's kind of the big question that I get. And the answer that I have to that is, are you production ready? Right? Are you comfortable enough with the technology and the techniques to run this in production? Of course, you have compatibility and all that fun stuff that you have to deal with your applications, but are you able to support this technology or these techniques to get your systems into containers? And I think over the next months and years, this is going to be a very predominant way in which applications at the data tier get deployed. Are containers perfect? No, there's other things that we have to worry about when we deploy containers. We have to worry about images and patches. We also have to worry about, are there any bugs in file system drivers? There's a huge bug yesterday in run C that came out. Don't run your applications as root. Things will be a little bit better. But these are things, it's another part of our technology stack that we have to learn, perfect, and manage, right? What's next for you is to drop some tweets on the Twitters about this session and tell everybody how awesome it was and that my demos failed, and I'm sweating as we speak because of that. But let's talk about what we talked about today. We introduced containers, so hopefully you guys understand what containers are and how they provide value for your applications and your data centers. We looked a lot at running SQL Server and the value that we can get out of running SQL Server in containers. We saw the awesome cute picture of the Docker whale, but also understand that Docker is the technology and the company. We did lots of demos with containers. I'll debug that script before I put it back on the website and get that out to you guys. We talked about container orchestration and the need for container orchestration, providing persistent services and features like replica sets and things like that to help enable some high availability scenarios and whatnot inside of our data tier, but also up into the app tier and leveraging that platform to do that type of work. Now, I do mean this sincerely. If you have a question, hit me up on Twitter, shoot me an email. I'll be glad to help you along. I blog pretty frequently. And if you're starting from scratch and you're not familiar with Linux or SQL Server on Linux or Kubernetes or anything like that, I have 3 courses out there that kind of tie into the technologies and things that we talked about today. If you want to shoot me an email, I can give you a 30-day free trial card, no questions asked. You go watch this content at your own leisure at no cost. And so I want you to have access to that for your own viewing pleasure. And so that is there for you guys. Some additional resources for installing Docker as promised. There's the way that we get it installed on Windows and CentOS if you are from the Linux arena, and some getting started tutorials on Docker itself. And so I'll jump back and leave that up for you guys and open it up for questions. Mark.
Awesome. Thank you very much for that. The first question, if there are multiple containers on one host OS, one physical machine, do they fight for CPU and memory?
Yes. If you look at this from underneath, it's not that they fight, but think about it like this. If you're running multiple instances of SQL Server on a Windows box, you're kind of left to making sure that each instance has the appropriate resources. And so even though we talked about namespaces and resource isolation, that's just a boundary from a visibility standpoint. It's not a boundary from a resource consumption standpoint. And so there are ways that you can add boundaries from resource consumptions, and that's where C groups come in to control the container's access to the physical resources of the underlying OS.
Do those C groups exist on Windows, or is that just a
Yes.
Linux? Okay, cool.
Yeah, it's called something else, but effectively the design paradigm is the same. C groups and namespaces, it's called something else in Windows.
Yeah, okay, cool. Kind of relate to this question. So this is Sir who's asked this one as well. Is it similar way of setting vCPU and vNUMA in containers as well? So I'll expand on that. I will basically pose the question as, would a SQL DBA still want to configure a container's SQL Server, settings such as what your max memory is and those kind of things?
Yes. So from that standpoint, you still have to treat SQL Server like SQL Server, right? And so those best practice configurations still apply. That's actually an interesting question about NUMA, because in 2017 and 18, when I did a lot of perf testing on SQL Server and Linux by itself, I was getting fuzzy answers about NUMA. And that really has to do more with the platform in SQL Server and SQL Server on Linux than it does with containers. And so I want to go back and revisit that after this so that I can get some more solid answers on how that would impact container standpoint. I would imagine running SQL Server in a container and the numinous of the underlying hardware wouldn't be any different than running SQL Server natively on the OS itself. And so I'm going to have to look and see how that all pieces together because of SQL PAL and things like that.
Is the time taken to containerize an application less than building a VM?
Yes, mostly because I can just do Docker pull MS SQL Server and get it down. No, I tried to make that point during the presentation. The best automation that I have for deploying just SQL Server, I know you asked about apps specifically, the best automation that I have leveraging VM templates and PowerShell DSC to stand up SQL Server automatically, like to go from basically templated VM to running SQL Server instance is about 2 minutes. Because either way, what's the smallest VM that you're going to have in your data center? 60 gigs if you're running Windows, right, on 2016? Absolute minimum, right? And that's not including any of the data directories and whatnot that are bolted on to the VM to support your data tier, right? And so literally you have to clone the template, which is going to burn 60 gigs. And so how long does it take you to copy 60 gigs, stand that up, get that joined to the domain, and then install SQL Server, right? That's a lot of bits and bytes being moved, where the difference is with containers, I have that single container image that I can use to source multiple containers running. Now, that container image has to be resident on the physical system. So like on my laptop, it was already here. If I had 10 servers in my cluster, in a Kubernetes cluster, well, that container image would need to be resident on the individual node in the cluster to stand up that fast. Otherwise, I would have to pull the 1.3 gigs down from wherever it would need to pull it from.
Next question from Yas. Can you please elaborate more about running Linux containers on Windows machines, e.g. Windows 2016 Server?
Sure. I haven't tested that explicitly because I generally run in the Linux and Mac arena, but the tech works like this. You install Docker. In Docker, you have the choice of running either Linux or Windows containers. If you're running Linux containers, you have to have Hyper-V, which basically means you have a stub VM under the hood that runs Linux. And so all of those system calls that would go to the underlying OS on a Linux or a Mac would go to that Windows VM that's kind of underneath Docker. Now, Macs have a similar technique, but it doesn't require an external hypervisor. When you looked at the demonstration when I did a Docker inspect, that's running on my Mac, but you saw var, lib, Docker. It was a Linux directory that was exposed because underneath the hood, even on my Mac, the kernel itself exposes a small hypervisor for Docker to interact with. And so Linux VMs running on Linux, no special sauce. Linux VMs running on Windows, Hyper-V. Linux VMs running on Mac, use the underlying Mac OS's kernel thing. I can't remember the name of the technology to expose the Linux subsystem to be accessed by the kernel for the container.
So there's been a couple of questions actually about connecting to containers using various tools such as SSMS, and also there's one specific question here about how do you pull data into reports from the separate containers. I think, well, my take on this would be that the way you connect to SQL Server isn't changing, you're just connecting to the exposed port. So would you go along with that?
Yeah, exactly. So here, if you look, I'm still presenting. So I just spun up that container on 1433. Let's go ahead and bring up Azure Data Studio here. And I'm going to go ahead and actually did this yesterday. I had to do a bunch of troubleshooting on an encrypted column issue for a customer. Let me go ahead and grab the SA password, connect. And there you can see I'm connected to Azure Data Studio for the Docker container that's running on the system. So this effectively would be over the network, even though I'm pointing at localhost. Yeah. So this could be anywhere on my local network or anything that's IP reachable to get to this machine, I should say.
So a question from Sam Bryant, how do we hook up AD to containers?
So there's no Windows auth right now for users in SQL Server on Linux. I know the jury's still out on that. I know there's some level of Kerberos integration for authentication, but I'm not incredibly familiar with that specifically. So for now, most of the applications that I've been working with are using just straight up SQL Server authentication.
You talked about volume mounts. Are there any reasons to still use legacy bind mounts over volume mounts?
You know, I researched this a bunch when I got involved in the container universe, and I actually had it in my deck for a long time. The primary reason that I remember that you don't want to use bind mounts is because you were tightly coupled to the volume itself, and you lost that ability to manage the volume as a Docker managed resource, right? And so that having that slight abstraction gave you some flexibility in how you can present that into your containers.
Yeah, I think that's my understanding too. I was playing with it the other day, funnily enough, and I was actually looking at the possibility of putting tempdb on a temp volume, tempfs volume mount, and
that's funny because I emailed someone in the product team that exact question about.
So have you tried it and it failed like me?
No, I haven't done it yet. I wanted to see like if it was a valid thing to do.
So I tried it, and it would not be able. It could not create a temp database on there, and I couldn't even get it to create any other databases on there. The strange thing is that there is obviously by default a temp file system, and I was able to create a database into there. So something strange is going on with my temp FS volume mount. So I don't know if I've done something wrong or not, but I'll be interested in your feedback from the product team.
Yeah, it makes sense because it's just going to expose itself into the file system at a particular location. Now it's a matter of how it interacts with that underlying file system, which is memory backed. And so I have to dig into see if that is going to work.
Okay, I'm going to make this a last question then.
Okay.
There has been a few more, but maybe we can send those to you. Right, so
Yeah, please.
I've heard that the one reason why, say for instance, you're on your laptop and using Docker, there are benefits to actually creating a one node swarm cluster on your laptop, because you can very easily use swarm functionality, such as one of the reasons given to me was swarm secrets in your container deployments. So obviously Kubernetes is ultimately the orchestration platform of choice. Now, are there any benefits to doing a one-node Kubernetes cluster?
Yeah, I mean, honestly, some of the service abstraction and things like that I showed you would be beneficial there. But, for me, I've had some good luck with just using bare containers for my like individual testing and playing around on my local machine. So I guess it's whatever gets you closer to whatever goal you're trying to reach with the technology that you're using. And I did want to point out, in both Docker for Windows and Docker for Mac, I think it was late last summer, you can get Kubernetes now by just checking the checkbox, which is great. It goes and it downloads all of the required containers and things like that and gets them up and running on your local system. Now, if you're on Windows and Linux, that's fine. If you're on Docker for Mac, there is an issue with that kernel stuff that I was telling you about inside of Mac OS that makes persistent volumes not work correctly. And so that is going to be an issue, and that's been on GitHub for a while, I think about 2 years, that hasn't been remedied yet on Docker for Mac. If you're on Windows and Linux, this works seamlessly. All
right, well, I just want to say thank you very much for giving the presentation. It's been very, very educational, and it looks like everyone's really enjoyed it. So hopefully we can get you back on sometime and
absolutely
do something else to confuse us all.
Hey, wait, don't confuse you guys.
Well, educate us all then.
Well, thanks for having me, sir. I appreciate it. Thank you.